Hi everyone, this is Mr. Schaefer. I'd like to walk you through an FRQ to help you prepare for your AP Calculus exam. This is a problem that involves a rate in and a rate out type of situation. And so to kind of explain to you what's happening here, we have fish coming into a lake, and then we have fish that are leaving the lake. And both of the functions are provided for us here, but we have to make sure we understand what kind of function they are. It says that fish enter a lake at a rate modeled by this function e. So here is the rate of change of the amount of fish that are entering the lake. So I might call that the rate in. Then fish are leaving the lake at, again, another rate, and this rate is given by L. I'll call that rate out. The units are provided for us here. E and L are measured in fish per hour, and time begins measuring time in hours since midnight when t equals 0. Let's dive in. Letter A. How many fish enter the lake over the 5-hour period from midnight, time 0, to 5 a.m.? And then it says to give your answer to the nearest whole number. So to find that out, to go from a rate to a number, I'm going to integrate. Let's integrate the e function from 0 to 5. So you should write down that integral. And then we're allowed to use our calculators on this problem. So I'm going to use the numerical integral feature on my TI-84 to compute the value, which comes out to be 153 fish, rounded to the nearest whole number. Make sure you don't just say the final answer, but that the integral expression that you typed in the calculator is also listed. This must be there in order for you to earn full credit. Now, letter B, what is the average number of fish? And that word average is very, very important. Don't forget the average value formula of a function. Average value is the integral divided by some interval. Average value. And it's the same 5-hour period. So we're going to have that same number. Oh, but notice here it's fish that leave the lake. So I've got to shift functions as well. If I integrate the L function from 0 to 5, that will give me the number of fish that have left the lake over the 5-hour period. But it says, what is the average number that have left in fish per hour? So divide that integral by 5 minus 0, or 1/5 times the integral of 0 to 5 of L. Use your calculator, and 3 decimal place accuracy should be listed there, 6.059. And the units here are not just fish, because we're dividing by a time interval. When I integrate L by itself, I will get amount of fish, but then I go and divide by 5, so it's fish per hour as my average number of fish. Letter C, at what time t is the greatest number of fish in the lake? Now, that's a complicated question in the sense that we've got to figure out kind of what's going on with fish in the lake. We have fish coming in, entering the lake. And then there are fish leaving the lake by the rate modeled by L. At any given time in the lake, the rate of change of fish in the lake can be modeled by simply E minus L. So if I want to find out the greatest number of fish in the lake, let's take the rate of change of the number of fish in the lake, which is E minus L, and set that equal to 0 to find a critical point. So set E of t minus L of t equal to 0, but that is essentially going to happen whenever E and L are the same. solve that equation for t by using your calculator. And we'll have a value of t equals 6.2035,644. Now, when we go to compare values, don't forget to, in a closed interval, we want to actually use the endpoints as part of our analysis. We want to test those endpoints. So from time t, I'll use capital A to represent the amount of fish in the lake. I have endpoints of 0 and 8. And my one critical point is 6.2035,644. So now let's just find the outputs. What's A of 0? What's A of my critical point? And then what is A of 8? The winner will be the maximum. Well, at time 0, we'll have there a value of 0. 6.2035,644 hours later. To find that, let's integrate from 0 up to 6.203. The rate of change of the fish in the lake, which again is E minus L. The rate in minus the rate out. Use your calculators. We should get about 135.015 fish. Do it again at 8, so 0 to 8. Rate in minus rate out. Use your calculator. 80.920 fish. So at what time is the greatest number of fish in the lake? Well, that would be here at time 6.2 hours. We're going to round to 3 decimal places. At t equals 6.203 or 04 hours, the fish in the lake reach a maximum. That whole process is called the candidates test. We found critical points, one critical point in this example, plus the endpoints, and we're comparing the outputs of the function in question to see where the minimum is, or in this case, the maximum. The greatest number of fish happened at time 6.204 hours. And lastly, letter D, is the rate of change in the number of fish in the lake increasing or decreasing? Key phrase right here is the rate of change increasing or decreasing? It's not asking me is the number of fish increasing or decreasing, but is the rate of the number of fish increasing or decreasing? That's a second derivative analysis type of question. Now remember that regular E and regular L are already rates. These are already rates. So the derivative of E is the rate of a rate. The derivative of L is also the rate of a rate. So E prime minus L prime would be essentially the second derivative. It's telling me how the rate of change of the number of fish in the lake is changing. Now it says here at time 5, so we'll plug in 5 for T. Again, use your calculator to compute those values. We should get a value of negative 10.723, and really all I care about is the fact that that number is negative. So because my second derivative is negative, that means the rate of change in the number of fish in the lake is decreasing. At 5 a.m., because my second derivative at time 5 is negative. So there's an example of a rate in minus rate out sort of an accumulation problem for your FRQ. I hope that helps you, and I hope that helps to clarify kind of how to approach and how to attack a problem like that if one occurs on your Calculus AP exam. Thanks for watching.